Well then, it's another exciting day for space weather, wouldn't you say? So we had a large, nearly X-class flare. It was like an M8 class flare. You'll see it coming from the eastern hemisphere, the closest star. That's a 24-hour video there from the Solar Dynamics Observatory depicting ionized helium, 304 angstroms. And yeah, we're gonna, fasten your safety belts because dag, that's a real word, by the way. It's another exciting daily space weather video. We've got an incredible amount of footage today. If you're into stargazing, you've come to the right place. Here we've added 131 angstroms, so we've got ionized iron and ionized helium here. These are also 24-hour videos. And they're also from my favorite telescope, the Solar Dynamics Observatory. Yes, the James Webb is good, the Hubble's good, and so on, but the SDO it's just... Anyway, there is one more new sunspot that rose over the northeastern limb. So sunspot group will be getting very close to 200 today. It'll be at least, it'll be at least 187 or so. So we've also got massive plasma filaments, as you can see up there. That is the Scott McIntosh solar prominence, I believe. Down here we've got the Eugene Bagashov solar prominence, which looks like it might have now collapsed. Anyway, we've got a lot of material to go through today, so let's not screw around. And by the way, we're not screwing around on the channel. So if you're new, make sure you press the subscribe button. Thanks to all of our new subscribers. The subscriber count has been blowing up here over the past few months. So thanks to everybody who has discovered the content. Frankly, we are surprised with the state of affairs on the internet. I'll just leave it at that. If you're into the most comprehensive daily space weather content in the known universe and the most detailed imagery of the closest star that you'll find anywhere, then make sure you press subscribe. And if you're not new to the channel, in any case, press that like button. Help us out with the algorithm. Press comment, press share, etc. And don't forget to visit our links in the description, which we will talk about in further detail right here. Today's featured product is one that I'm wearing. Universum Liberate. It's why I'm partially keyed out here. I'm also wearing the Mensa hat, which, by the way, stands for Make Earth Not Suck Again. Because the best way to get out of a hole is to stop digging. But when I say Universum Liberate, what I mean is, if I could wave my magic wand, I'd set everybody free. That's a quote from Rush. And, yeah, put some Latin lingo on your clothes. You know, Latin terminology. That'll convince your friends and your foes that you're in the Illuminati, perhaps. They will be very frightened. So, hey, Machiavelli said, I'd rather be feared than loved, right? So anyway, in any case, Universum Liberate. It is the motto of the Galactic Federation Special Forces. It's today's featured product, linked below the video in the description, along with 36 other designs from the Redbubble shop. Today's featured product on the Hemp Lucid shop is where you can save $15 on sleep stacks, stress stacks, immune stacks, or even more than that if you buy the full stack package. So save some dough via our link on the Hemp Lucid shop. That's one of our affiliate/sponsored paid links. You can also find links on the homepage at smashomash.com. Today's featured product from the Amazon storefront is Cameron's Coffee. Folks, switch to organic coffee. I mean, switch to organic coffee. This might look like it's expensive because it is $23.38 for that coffee. However, that is a 4-pound bag, so it's actually not that expensive. If you are paying a bunch of money for specialty coffees that are not organic, you're screwing up bad, folks. You're screwing up bad. We stopped getting the jitters when we switched to organic coffee. I'll just leave it at that. Not making any health claims about it, but 4-pound bag there of Cameron's Organic Scandinavian Blend Whole Bean. 4-pound bag, for $23.38 at amazon.com/shop/smashomash. You can find links on the homepage as well as below this video in the description. So make sure you check it out. Smashomash.com. Come visit us on the internet. We built a massive web ring for people just like you because in 2018, a crack YouTube unit was sent to social media prison for a crime we didn't commit. We promptly escaped a maximum security social media stockade of the internet underground where we survive as producers of fortune. If you have a problem, if no one else can help, and if you can find the content, maybe you can hire the Smash team. More on that at the end of the video at our meteorology segment. Smashomash.com. Again, welcome to the Renaissance. And here is the latest conflagration of sunspots. Check out the number of sunspots we've got here at the moment. It's, once again, folks, it's pushing, if not exceeding 200 sunspots here. So that is a lot of sunspots. That is yesterday plus today from the SDO's HMI instrument showing the photosphere. And here are the magnetic fields of the photosphere in convenient colorized magnetogram. Of course, the sunspot that produced that large flare was this Beta Gamma Delta class sunspot moving right into the center of the Earth-facing solar disk. Again, we did have one new sunspot rise up there in the northeast. You can just see it popping over the horizon there. That just rose in the past few hours. Next, let's see what's going on Earth for a brief moment. Our viewers are interested in which volcanoes are erupting, and so am I. So here's the list. Subanose-jima is producing a 6,000-foot ash plume. Mayan's producing an unknown volcanic ash plume, so please don't pole vault the caldera. It could be unhealthful. We don't want you to become part of the lithosphere. Luatolo is exploding, flight level 070. It's a 7,000-foot ash plume over the Lesser Sunda Islands. Dukono on the Indonesian island of Halmahera exploding, flight level 080. Popocatépetl producing a 22,000-foot ash plume over central Mexico. As it explodes, it's a flight level 220. Fuego in Guatemala, 15,000-foot ash plume as it explodes. Sangay in Ecuador exploding, flight level 210. It's a 21,000-foot ash plume. Ravenador exploding, flight level 150. Sabancaya exploding, flight level 260. It's a 26,000-foot ash plume. And last but not least, Villarrica remains active. Do we have a volcanic ash plume size? Well, no, but some emissions were rising above the crater, 50 meters above the vent. Let's just move on to earthquakes, as we did have one quake of a 6 or greater magnitude. There's the 90-day bar graph for you, and there's that 6 magnitude quake. It occurred in the middle of nowhere in the southeastern Pacific. Not a lot of people around to feel that 6 magnitude quake. That happened at 14:45 Universal Time yesterday on September 20th. So here are the quakes that are a 5 or greater. 5.2 in the East Central Pacific rise, so a foreshock there. And remember, folks, any earthquake can be a foreshock, including that 6.0. So just so you are aware of that. And then an aftershock. So there's a 5.7 aftershock in that same region. We also had a 5.8 at Prince Edward Island. Another very desolate region there, south of Africa. That 5.8 occurred at 1922 Universal Time yesterday evening. We also had a 5.4 in the Aleutians there, actually near the Alaskan Peninsula, I think. That 5.4 occurred at 1:13 Universal Time this morning on September 20th. And one more 5+ magnitude quake here. This 5.0 occurred at Guam. That one was at depth. It was at 9:48 Universal Time this morning at a depth of nearly 150 kilometers. And it's time to return to space. Here's a 24-hour video from SDO. That is 171 angstroms, the house favorite wavelength. And while that wavelength isn't as good at showing solar flare activity, it is quite good at showing the lower corona. Anyway, the 10.7 centimeter radial flux has dipped since yesterday. It's now at 156 solar flux units. There it is in a convenient 1-year graph for you, depicted by that black line. I would note that the 81-day moving average for the 10.7 centimeter radial flux is at about 165. So dropping a little bit below the 81-day moving average. We may see this rise back up here again in the coming days here with as many sunspots as we have. So there you can see the sunspot number there crossing the radio flux in the past couple days. That's the red line. Again, sunspot number will be well into the 180s in the next 36 hours. Space weather enthusiast dashboard here forecasting, just like we did, forecasting some geomagnetic unrest. We think it might come a little bit earlier, sometime late in the day on the 22nd, maybe even later tonight. But so some CMEs about to strike Earth. One of them was associated with that large M-class flare. We will talk about it. We're going to also show you NOAA's forecast here. So NOAA's forecast is showing geomagnetic unrest late in the day tomorrow, September 22nd, and into Saturday, September 23rd. And here's NOAA's Enlil spiral. So let's see if they have that latest one modeled as well. So that's NOAA's forecast. And here's NASA's forecast. So NASA is showing a glancing blow, a shoulder strike, a brush past of that CME that was generated yesterday, the one associated with that M8 class flare. NASA expecting that to arrive at Earth sometime late in the day of the 23rd, early in the day of the 24th. So I tend to agree with that. Let's move on to take a look at Earth's magnetic moment from space for the past 4 hours, and we have a very diffuse solar wind as measured by one spacecraft and a very normal solar wind as measured by the other one. So this model is using the extremely diffuse solar wind as measured by, I think that's the ACE. The Discoverer is showing a much denser solar wind here, so this model might be erroneous. That is the past 4 hours of Earth's magnetic moment from space, looking very low pressure. Here's Earth's magnetic moment from the ground, geomagnetically calm conditions on planet Earth here at the moment. This depicts magnetic flux density at the surface level. Again, it may be underestimating because of the solar wind data, which we'll show you here in a minute. Let's let that play all the way through anyway, just for the sake of data archiving. We do show this daily on the channel to at least get 4 hours of Earth's magnetic moment from the ground. Again, geomagnetically calm conditions. We have a KP 1.67 at the moment. Following that significant geomagnetic storm, it was the Tamitha-Skov geomagnetic storm. And lots of auroral imagery around the world from that. Next, looking at the real-time solar wind, and I'm going to show you some features here that we don't normally show on the channel. So here's the real-time solar wind from the Space Weather Prediction Center. And if you pull up series, it will be defaulted to the active spacecraft. So at the moment, we have the ACE is the active spacecraft. And if you switch to the Discover, you'll notice that the solar wind is much higher density there. Solar wind there, 7.2 protons per cubic centimeter. Whereas the ACE, which is the current active spacecraft for whatever reason, showing erroneously low readings. So that doesn't mean that the one is wrong or anything like that. It just means that, keep in mind, those spacecraft are both orbiting Lagrangian point 1, 1,000,000 miles away from Earth outside the magnetosphere. It's entirely possible that the ACE is measuring a really diffuse solar wind. It's probably more like 2 protons per cubic centimeter, or as low as 0.14 protons per cubic centimeter. That's extremely, extremely low. So the Discover coming back with much more reasonable solar wind parameters there. About 7 protons per cubic centimeter for the solar wind density, solar wind velocity here, nominal at 446 kilometers per second. That's what we'll report. And again, keep in mind, folks, those models that we showed, the space weather modeling framework, it does rely on the active spacecraft. So if the active spacecraft is sending back extremely diffuse solar wind, then that's what the model looks like. Anyway, moving on to the GOES magnetometers here, fairly smooth for the past 24 hours, following the subsiding of that geomagnetic storm, where it was a little bit more choppy, although not particularly extreme. And let's take a look at the heliospheric current sheet next, because this one is about to show a sector boundary crossing. So Earth is about to move into a North Pole current sheet here. It may be delayed. It all depends on how strong that sunspot in the northeast is. So if that sunspot turns out to be a very powerful, strong, magnetically complex active sunspot, there may be a delay in the arrival of the North Pole current sheet. If you look at the latest image, it looks like it's only a few hours away, but that could extend. So I'll say that by tomorrow's video, though, Earth will be in this North Pole current sheet, having passed this sector boundary crossing, moving from a South Pole current sheet to a North Pole current sheet. Next, the line of sight field plot. And keep in mind, folks, these images show 4 days of activity from the National Solar Observatory. And yeah, that's what the solar B field looks like in blue, polar fields in red and green for south and north respectively. Grayscale depicts the photosphere magnetism. And that brings us to coronal holes. So here's the coronal hole situation. We are expecting a small intensification from coronal hole high-speed winds. That's going to be showing up around late in the day tomorrow as well. So we have forecasted a CME here that NOAA and NASA didn't forecast. It looked like a stealthy CME to me. They didn't really model it at all. So yeah, so multiple events here are going to be showing up. It could muddy the waters a little bit, but that's the situation with coronal holes. We've got North and South Pole coronal holes facing Earth. Let's take a look at the view from SDO. There's a 24-hour video from SDO. This one right here is the one that NOAA is forecasting will cause an intensification in the solar wind late in the day tomorrow. So I'll agree with that, but also early in the day tomorrow, possible CME impact, coronal mass ejection. So those are the facts. And let's move on to sunspots. Man, oh man, a lot of sunspots. And we've got some incredible imagery for you today of sunspots. So let's see. Here's a group that doesn't have a name yet. That sunspot group ought to have a name by now. And then there are 2 more groups in the northeast, I believe, that don't have names yet. So again, we'll see a big increase in the sunspot number. Likelihood of large solar flares remains intact. And right now the active one is actually this one right here, which is 3433. Anyway, here comes some sunspots. Check this out. So here's the SDO magnetogram, another 24-hour video. And we're going to zoom in a lot closer on that flare-producing sunspot. Just to show you the magnetic complexity, you're going to see a lot of black and white close to each other. That's the feature of a beta gamma delta class sunspot group. So that sunspot still does have quite a lot of magnetic shear, as it's called. You've got opposite polarity umbrae very close to each other. As that system tries to reach static equilibrium, that is the kind of sunspot that is still certainly capable of producing large solar flares. Here it is in the other HMI instrument, the HMI continuum from SDO. So that sunspot group hasn't changed a lot, although the leading umbra have shrunk a little bit since yesterday. Looks like some new umbra are forming to the north of that largest group. Showing some great evolution there of that sunspot group. Here is the full disk equatorial view. That'll show all the sunspots. And again, that's a lot of sunspots. Rapid growth of this group up here, which doesn't have a name yet. That'll get a name today. Also this group up here, and then another group up there. So, yeah, it's that's a lot of sunspots. Here's ionized carbon. This is the SDO AIA instrument, 1600 angstroms. And you see some activity right at the end of the video there in the upper right, as that new sunspot rapidly grows and creates carbon. Also a possibility of flares there in the northeastern limb where that new sunspot is rising. We're going to keep this thing moving as quickly as we can. Here's yesterday plus today in 94 angstroms, which brings us to solar flares and energetic particles. So the solar flare section today is going to be quite sweet. And by the way, that large flare yesterday didn't produce any relativistic particle events, so the ghost proton flux there remains flatlined. It's just baseline levels. No relativistic particles. And here's that largest flare. Let's zoom into a one-day view for a brief moment. Oh, it's not going to work. All right. Anyway, peak flux was around 1410 universal time. And that was an M8.2 class flare, approximately. Something like that. M8.23 was the peak flux. And let's cut back to the SDO. So that's the full day yesterday on the 20th plus the 21st to date. We've got some berserk imagery for you here. Some extreme close-ups of that flare in slow motion. So most of our 24-hour SDO videos depict 24 hours, obviously, at 30 frames per second. This is only 3 hours at 10 frames per second. So there is the 131 angstroms wavelength. Here's 171 angstroms. And yes, it is showing you a different part of the corona. Here's 1600 angstroms. It looks like a lot of carbon got built. Or perhaps it was nuclear fission. Perhaps a combination of fission and fusion, but in any case, a lot of hot carbon there showing up at the time of the flare. Perhaps that's blasphemy when it comes to astrophysics, heliophysics, cosmology, etc. And here's 335 angstroms. Once again, this is ionized iron, by the way. We'll let it play through a second time here. Pretty sweet, right? We've also got 304 angstroms, the ionized helium wavelength. And we'll allow that to play through a second time. Again, these are only 3-hour videos, but we've slowed them down to 1/3 of the normal speed. That's 10 frames per second instead of 30. Yowzers. Anyway, here's the full disk image. The equatorial zoom there. The full day yesterday plus today. That's September 20th and September 21st to date. Moving right along, it's time to go to our star chart. As I guess part of space weather is what's going on overhead, right? So there is what's going on overhead where we're located in Lehigh Valley, Pennsylvania. Jupiter being chased by Venus, being chased by Mercury, being chased by the Sun, being chased by the star across, being chased by Mars across the ecliptic. That's what's going on overhead here. You can build your own at skyandtelescope.org if you like. So that's what's going on overhead. And here is your solar system forecast. We'll advance this 1 week. We'll be approaching the September full moon by the 28th. That is where things will be located at that point in time. And just a quick reminder that the equinox is coming. Yeah, the equinox. It's almost here, folks. We are almost into fall. So it comes on Saturday, September 23rd at 2:50 a.m. Eastern Time. You can make your countdown to the equinox if you like there at timeanddate.com. And we will not be streaming live for the equinox. I will be asleep, hopefully, at the moment of the equinox. Now, today's astronomy photo of the day is totally sweet. Guess what's going to happen Sunday? OSIRIS-REx is going to drop off a portion of the asteroid Bennu. How awesome is that? This imagery depicts the touch-and-go procedure, where OSIRIS-REx briefly landed, picked up some material, took back off again, and it'll be arriving on Earth on Sunday. From there, OSIRIS-REx will continue on to go orbit another near-Earth asteroid called Apophis. So how you like them apples? That's pretty sweet, right? Now, I'm not super excited about things like planetary stuff because cosmology and heliophysics, that's sort of my thing, but still great stuff there, returning some material from the asteroid Bennu. So that's the astronomy photo of the day at apod.nasa.gov. And let's move on to coronal mass ejections. Again, there's another one headed this way. Expected to arrive late on the 23rd, early in the day on the 24th, something like that. And there it is. You can see it kind of popping off from the eastern portion of the closest star there. Not a direct Earth hit. Most of it will miss Earth to the east. That's 102 frames from yesterday. And here come today's frames. 42 frames from today. Doesn't look like any other CMEs headed this way since. Continuing on, here's the Soho Lasco C2 and C3. That last imagery was just the C2 and the difference imagery. So no new CMEs. At least not earthly directed ones, just minor outflows happening here. We'll also show stereo A, we usually do. By the way, the solar orbiter is on the other side of the sun right now, so people are a little bit stressed about that. It'll be fine. Couple days, it'll pop back into view, and communication will be restored. Anyway, here's stereo A, difference imagery, and stereo A raw coronagraph on the left, difference imagery on the right. Exciting times for space weather. And we didn't accidentally leverage ourselves here, folks. I realized in about 1994 that there is a hole in cosmology based on heliophysics. And so I'm back. And what's happened is I've ended up with answers to questions not asked. So let's continue on here. We don't want this video to be too lengthy. Here are our custom coronagraphs. Another 24-hour video at 30 frames per second, by the way. There you'll see that CME popping off just after that M-class solar flare. A bunch of plasma motions happening there associated with that flare, right in the Earth-facing portion of the center of the solar disk. Coronal holes opening and then rapidly closing there. A little bit of stellar excitement happening. And we are excited and delighted to bring it to you in such spectacular detail. Next we'll show filaments, which they do show up rather well in that 193 angstroms wavelength. They show up a little better on the Hydrogen Alpha telescope here at El Teide, Spain. So there's the El Teide, Spain Hydrogen Alpha imagery. And a big portion of the Reed-Timmer filament has reformed here, so that's interesting. Part of it ejected. We're expecting part of that to arrive again sometime late in the day tomorrow. Or sometime throughout the day tomorrow. I'll just say that. So the main filaments are over on the eastern limb at the moment. There is a large crown filament as well up at the North Polar region. It's becoming slightly prominent. It looks like the Scott McIntosh filament might be ejecting. Also, part of the Eugene Bagashov filament is still hanging out down here. And this one here could get a name. I mean, that would be a good filament to name right there. That is quite likely to become a coronal mass ejection. And if you want to name filaments, make sure you do it over on Twitter. By the way, thanks to our new Twitter followers and so on. Congratulations on realizing that the Twitter channel exists. Twitter, where censorship continues and people keep swearing that it's been fixed. Pretty pathetic. Just one of the many cults is the Elon cult. Check it out, a flare happening as we create the video. Looks like a pretty decent sized event too there as we produce. Let's take a look. Has it already reached peak flux? And it looks like it has. There it is, the sun weighing in on our videos once again. Happens all the time. The largest flare of the past couple of days there, an 8.7 M-class flare, an M8.7 flare there happening while we create the content. So there it is, happening just in the past few minutes. How's that for up-to-date space weather content? Geez. Again, if you want to name filaments after living people, do it over on Twitter. If you've unplugged from social media entirely, we don't blame you. It is pretty pathetic out there, especially with the state of censorship. We are working very hard to make Earth not suck again and to set everybody free. Universum liberate, once again. Again, thanks to our new Twitter followers. Here come bonus features. Satellite charging hazards are non-existent. So, yeah, no satellite charging hazards there, according to the Satellites Community Dashboard. Next, there goes electron flux, which is going to go back into warning levels today. So we did get pretty high levels here yesterday. Not extremely high, but we are expecting warning levels to continue here until the CME strikes sometime probably around midday tomorrow. There's the one-year graph to put it in context. That's the relativistic electrons measured at the F flare by the GOES 16 and GOES 18's radiographic measurements. And it looks like NOAA's expecting a small decrease in the electron flux today. Nearly flat levels there in the forecast by NOAA. The green boxes are the forecast. Again, it's measured at the F layer of the ionosphere. We show the ionosphere daily as well. A lot of people are spooked that we've reached doomsday. And the ionosphere is one of the many things that shows us that it's not doomsday. The polar excursion isn't scary at all. It's not even what you would call a polar excursion. At least a geologist wouldn't call what we're seeing currently a polar excursion. Anyway, there's the vibrational frequency of the ionosphere, and we're not seeing any quadrupoles or hexapoles or octopoles forming on planet Earth. Cosmic ray flux isn't all that high. In fact, cosmic ray flux is the lowest it's been since 2004. We would have covered it today, but there's too much solar imagery on today's video. We'll have to wait till tomorrow to cover cosmic rays. Anyway, that's what's going on in the ionosphere, the bridge between Earth and space. The F flare is at about 300 kilometers of altitude. And let's show the anomalogram. So there's the anomaly in megahertz from a 30-day median. And keep in mind, folks, as we approach the equinox, geomagnetic storms are more likely and more intense as a result of the Russell-McLaren effect, where relativistic electrons are accelerated in the outer Van Allen belt. It has to do with the angle of attack of incoming particles, Earth's magnetosphere versus those incoming solar particles. They're more perpendicular at the equinoxes, and that makes more excitation happen in the outer Van Allen belt, where those relativistic electrons are accelerated to higher speeds. That's one of the mechanisms that drives space weather. And let's bring up the latest image here once this plays through. There is 1300 universal time on the ionogram and 1300 universal time on the anomalygram. We also show total electron content forecast. Feel free to pause the video on this frame if you're not familiar with distances in miles. That's where things are located. And here is the count. It's the free electrons from your GPS satellite down to your handset. Literally, it's a count of free electrons to about 12,500 miles of altitude. Those are the most likely places to see GPS errors around planet Earth, and things are pretty organized, as they typically are at times of high electron flux. No surprise to our regular viewers. And here is the total electron content anomaly over North America. It's the anomaly from the 10-day average, and things aren't looking particularly anomalously. We're almost on to our meteorology segment, which includes snow. Yes, snow falling during summertime, actually. Anyway, there's the latest intensitygram, and there's the latest magnetogram. Let's check out this new sunspot. It's looking fairly modest. So far, it is only appearing to be an alpha-class sunspot, as I only see one umbra, which does not reduce the number of sunspots, it increases it. So that is a lot of sunspots, pushing 200. I wouldn't be surprised to see this go over 200. And by the way, I don't try to count sunspots because every umbra counts as 6 sunspots, and it's not. I don't try to do it because it's complicated, and it's there are different versions of the sunspot number. I'm not going to get into it. Let's just get to our meteorology segment here. We don't want the video to be too long. It's already getting lengthy. We've got some very cold temperatures in the U.S. here, so that's the point. Places in Colorado are below freezing. Places in Montana, Washington, Idaho, Oregon, California, Wyoming are currently below freezing or close to it. And there is snow falling in lots of places. Now, the coldest place in the world is still down here. It's about to be spring, but it's 70 degrees below 0 Fahrenheit, parts of Antarctica. And if you want to know what the hottest place in the world is, it's probably up here. Over 110 degrees up there, so that's some idea of the Earth's extreme temperatures. I'm sure Saudi Arabia is kind of on the warm side there also. It's around 110 degrees there. Check out the cold temperatures down in Australia down here. Also Tasmania. Tasmania, 27 degrees Fahrenheit there. Anyway, here are the surface winds of the eastern world. Here are the jet streams. We show them daily on the channel. Here are the jet streams of the central world, like Europe, Africa, and the Middle East. And here are the surface winds. Surface winds of the west, depicted right there. And there are the western world's jet streams. Next, check it out. We've already got snow in the U.S. And quite a lot. Check this out. Yowzers. Geez. 10 feet of snow up there. All right. Nice. And yeah, there's snow in the forecast, folks. Wyoming will have the most by Sunday at 10 o'clock Eastern Time. Anyway, here's clouds and fog over the Americas, depicted by shortwave radiation. Since part of that map is still dark, that's what's going on in terms of clouds and fog as a low forms off the coast of Florida. Next, our weather.gov map, and look at all the freeze watches and warnings. Summer is not over, but frost is already showing up. Some of those parts of the planet are so hot that they're cold. Here's your smoke forecast. Heavy smoke there around Northern California. The entire west coast there, kind of smoky. Is it because they legalized pot? No, it's because of wildfires. And here comes some weather forecasts. So first, the GFS 72-hour pressure and precipitation forecast. You're going to see heavy rain making its way up the Chesapeake there, Saturday into Sunday, as snow falls in parts of the western U.S. So here is temperature anomaly forecast, and you can see that northwestern part of the country there, anomalously cold. Also anomalously cold temperatures coming to the mid-Atlantic states as that low takes control of things moving into the weekend. Very warm temperatures around the Great Lakes, Texas, and wild swings in places like Missouri. 72-hour GFS temperature anomaly forecast in degrees Celsius. And of course, some of those cold temperatures are going to bring some snow accumulation here to Nevada, Oregon, Washington, Idaho, Montana, and mostly Wyoming. Also Colorado and Utah expecting some flakes to fall. That's your GFS 72-hour total accumulation snow forecast in inches. Some places there expecting over 8 inches of snow. In fact, some places there expecting pushing 2 feet of snow, as I see some green showing up in some limited areas of Montana. That's a way to end summer. Next, our total accumulated precipitation forecast, and South Dakota here expecting some extreme rain. Also, Texas and Oklahoma expecting some extreme rain, and then that system has moved inland a little bit, so Virginia and North Carolina, parts of Maryland also expecting like 4 inches of rain there. That's the GFS 72-hour total accumulated precipitation forecast in inches. DAG. Next, our lightning mapper. That's where the lightning's been striking. Let's see if we have any current terrestrial strikes. But before we do that, consider becoming a member of the Smash Team. If you enjoy this content, support the channel. The best way to do it is to become a member of the Smash Team. You get additional content that way. You can even get email alerts, even at the bronze level, which will cost you $0 per month. Smashomash.com/Smash Team. These videos are brought to you in part by Gold and Silver Smash Team members, who also get additional content, like I just said. And here's your real-time lightning map, and you can see how straight this line is getting. Why? The day-night terminator is going to be perfectly oriented north and south at the time of the equinox, which again comes on, Sunday morning? We do have some terrestrial strikes here in Nebraska. It looks like Sioux City is in the crosshairs for some thunderstorm activity, and we'll close out this video with the U.S. Doppler radar map. Clouds and fog. And there is the water vapor. Here is your recap. We've brought you the weather all the way from the closest star down to the lower 48. U.S. Doppler radar depicts vertical motion in the air column. Ground-based systems. These space-based systems depict infrared radiation in the shortwave portion of the infrared spectrum. It shows clouds and fog, even though half the country is dark. And this one shows all of the water vapor, a different portion of the infrared spectrum. The most useful satellite imagery for if your Doppler is not giving you the full picture, especially if you understand atmospheric physics. Anyway, thanks for tuning in. Congratulations on realizing that channel exists. I've been your host, Dan, a.k.a. Smash-O-Mash, doing his best to make Earth not suck again. And we'll be back tomorrow. In the meantime, may that solar wind be at your back.